Assalamualaikum. My name is Farha binti Hamidi. In this video, my groupmate and I will present to you about our mini project assignment for subject linear algebra 2, which is MAT523. For this project, we want to identify the best fit curve of road crashes in Malaysia. So we have chosen 20 data of road crashes from year 22 to 2021. Hence, it shows the relationship between number of road crashes as S and number of deaths as Y. Next, we are going to use 4 mathematical models to find the best fit curve for the data, which are linear model, quadratic model, cubic model, and quartic model. We are required to find the best fit curve for the data and the error magnitude. As a result, we can determine which mathematical model will give the best approximation and has the minimum error in the term of its magnitude. Firstly, I will begin the basic mathematical model, which is linear model. As you can see here, the equation for the linear model is y equal to a plus bx. Therefore, the 20 data that we have, we can substitute the value of x and y into linear equation. After that, we can set up the matrix for M with dimension 20 by 2 elementary of Y with the dimension of 20 by 1. We calculate M transpose M, M transpose Y, and M transpose M inverse by using maple. Next, we substitute the value into the least square solution to find the best fit linear curve. And we get y equal negative 2413.2768 plus 1.657258s for the best fit curve. Then we calculate the error of vector by using formula E equal y minus mv. We'll also calculate the magnitude of error by using maple and get 324.6644.8062 over 4.6167.17715. So this is the graph of the best fit curve of linear model. And this is the graph of error vector around the x-axis for the linear model. Both of these graphs will obtain from maple application.
Hi, Assalamualaikum. My name is Swaila and I will present to you guys about quadratic model. Quadratic model is a mathematical model represented by a quadratic equation which is y equal to a plus bx plus cx squared. So there are 20 data that we can put them into these quadratic equations, which is y is represented for a number of deaths while x is represented for a number of crashes. After that, we set up the matrix based on the previous data, become matrix MV equal to y as shown here. For the first column, we put the value of 1. For the second column, we take it from x value, which is number of crashes. And the third column, we put the value of x squared. When we transpose the matrix M in the previous slide, we will get like this. For the next step, it is the same like linear model, where we find the value for M transpose Y. After that, we multiply it with the matrix Y, so we get the value for M transpose Y from the maple. And lastly, we find the inverse of matrix M transpose M by using maple. When we get all the value of the M transpose Y, M transpose M, and also the inverse of matrix M transpose M, then we can substitute the value in the normal equations and the least square solutions to find the best fit quadratic curve. Next, we find the error vector by using formula E equal to y minus mv. After we calculate by using the maple, we get all of the E value in matrix 20 times 1 as shown here. Then, we get the value for the magnitude of error vector. This is the graph for the quadratic best fit. Meanwhile, the other graph represents the graph of the error vector.
My name is Nurul Adlin binti Cekman and I will present to you cubic and quadratic model. So we go for cubic model. As you can see, we use cubic model equation y equal to a plus bx plus cx squared plus dx cubed. There are 20 data that we can put in this cubic equation, which is y present to number of death and x present to number of crashes. We set up the matrix of M by using values of cubic equation just now. It's similar like linear and quadratic model, but for cubic matrix M has 4 columns. By using maple, we find the M transpose and get the value. We calculate M transpose M and M transpose Y by using maple, and we substitute the value in normal equation. Then we calculate the M transpose M inverse in maple to use in least square solution to find the best fit cubic curve. The value of best fit cubic curve is y equal to 55260.372 minus 3.376398x plus 0.000117x square minus 9.912715x 10 power of 13 x cubed. Next, we calculate the error vector by using formula E equal to y minus mv, and then we find the magnitude of error vector by using maple and get 821.8334. So this is our graph of best fit curve against its observed data. And this is our graph of residual error vector against x value. Next, we go for quadratic model. We use quadratic model equation y equal to a plus bx plus cx squared plus dx cubed plus ex to the power of 4. There are 20 data that we put in this quadratic equation, which is y present to the number of death and x present to the number of crashes. We set out the matrix of M by using values of quadratic equation just now. It's similar like linear, quadratic and cubic model, but for quadratic matrix M has 5 columns. By using maple, we find the M transpose and get the value. We calculate M transpose M and M transpose Y by using maple, and we substitute the value in normal equation. Then we calculate the M transpose M inverse in maple to use in least square solution and to find the best fit quadratic curve. The value of best fit quadratic curve is y equal to 1739.19.843 minus 11.317725 x plus 0.000227x square plus 2.99824.879 times 10 power of negative 10 x cubed minus 5.86217708 times 10 power of negative 19 x power of 4. Next, we calculate the error vector by using formula E equal to y minus mv, and then we find the magnitude of error vector by using maple and get 640.4571. So this is our graph of best fit curve against its observed data. And this is our graph of residual error vector against x values.
For the conclusion, as we can see, quadratic model has the minimum error in terms of magnitude error, which is 640.457. Therefore, we can conclude that the best fit curve in this case that will give the best approximation is quadratic best fit curve. So, I think that's all from our group. Thank you.